let's consider S3 and the subgroups H1 and H2. So H1 is isomorphic to Z2 and H2 is isomorphic to C3, if you like, cyclic group with 3 elements. And let's look at the cosets. We'll start with the left cosets of H1. So E times H1 is just H1. So the set with elements E and 1, 2. And that has to be the same as 1, 2, H1. Now take an element, a group element that hasn't appeared in a coset so far, for example 1, 3. Now 1, 3, H1, that's 1, 3. And now we have to multiply 1, 3 with 1, 2. And that's just, well, 1 is mapped to 2. And 2 is mapped to 1, but 1 is mapped onto 3. And 3 is mapped back to 1. So it's 1, 2, 3. And that's the second coset. And that has to be the same as 1, 2, 3 times H1. And now what's missing? 2, 3 times H1. What's that? There's a 2, 3 here. And then we have to multiply 2, 3 with 1, 2. So 1 is mapped to 2, and 2 is mapped onto 3, and 3 is mapped back to 2, 2 is mapped to 1. Fine. And this coset is of course the same as 1, 2, 3 times H1. So these are the left cosets. And let's also determine the right cosets. The first one is identical, H1 times E. It's just a subgroup itself. And that has to be the same as H1 times 1, 2. Now let's look at H1 times 1, 3. There's of course a 1, 3, but this time we have to multiply 1, 2 with 1, 3 in the other order as before. So 1, 2 times 1, 3, what's that? 1 is mapped to 3, 3 is mapped to 1, 1 is mapped onto 2, so it's the other cyclic permutation, 1, 3, 2. This is our second coset here, and that's identical to 1, 3, 2 times H1. And then the third coset, 1 H1 times 2, 3. That's just a 2, 3. And now we have to multiply 1, 2 with 2, 3. And we get 1 is mapped to 2, and 2 is mapped onto 3. 3 is mapped to 2. Was that right? No, 1 is mapped to 2. Here, nothing happens here, and here 1 is mapped to 2. Sorry, 2 goes here, and 2 is mapped to 3, and 3 stays. And 3 is mapped to 2, and 2 is mapped onto 1. Fine. That was the last remaining element. And this is the third coset, H1 times 1, 2, 3. So we see that here in this example with H1, the left coset corresponding to 1, 3 is different from the right coset corresponding to 1, 3. And we can always take all the cosets, and the union, the disjoint union of the cosets, is just the group again. So H1 union with, let's say, 1, 3, H1 and 2, 3, H1, that's S3. Now let's look at this other subgroup here, subgroup H2. The interesting point is that this H1 here is just a subgroup, but this H2 is a normal subgroup. H1 is not normal. Now what happens with the normal subgroup? Let's determine the left cosets. E times H2 is just H2. So E 1, 2, 3, 1, 3, 2. And that has to be the same as 1, 2, 3, H2, and the same as 1, 3, 2, H2. Now let's look at 1, 2 times H2. What's that? There's a 1, 2, first element. And now we multiply the 1, 2 with 1, 3, 2. And we get 1 is mapped to 2, 2 is mapped back to 1. Okay, we can remove that. 2 is mapped to 3, and 3 is mapped to 2. And 2 is mapped back to 1. So that looks wrong. Let's try again. 1 is mapped to 2, 2 back to 1. Okay, fine. 2 is mapped to 3, that's where it stays. 3 is mapped to 1 here, and 1 is mapped back to 2. So we can just close this here. Fine, that's what I expected. And the third element, we have to multiply 1, 2 with 1, 3, 2. And we get 1 is mapped to 3, and nothing happens to 3 in the other permutation. 3 is mapped to 2, and 2 is mapped back to 1. So let's close this parenthesis here. Fine, we found the second coset. And that's of course the same as 2, 3 times H2, or 1, 3 times H2. On to right cosets. What about H2 times E? Well, that's of course H2 again. Elements E, 1, 2, 3, and 1, 3, 2. And that's automatically identical to H2 times 1, 2, 3, and to H2 times 1, 3, 2. Now, what about H2 times 1, 3? There's a 1, 3 in here, and then we have to multiply 1, 2, 3 with 1, 2. 1 is mapped to 2, and 2 is mapped onto 3. Should check. 3 is mapped back to 1. Fine. Last element. 1, 2, 3 times 1, 2. So what happens here? 1 is mapped to 2, 2 is mapped back to 1. You can remove that. 2 is mapped to 1, and 1 is mapped on to 3. 3 is mapped to 2. And that's the same automatically as the right cosets H2 times 1, 3 and H2 times 2, 3. And now in this case, left and right cosets are identical. So for example here, you see coset is just the transpositions. And as before, the group, or all group elements, are just the union of the different cosets. So it's H2 union with 1, 2, H2. Now in our example for the non-normal subgroup, left and right cosets were not identical, but for the normal subgroup, they are identical. And that's actually no coincidence. That's true in general. So if H is a normal subgroup of G, then left and right cosets are identical. And in order to see this, we have to only recall what it means for H to be a normal subgroup. it means that GH G inverse is H for all G in the group, and that's of course the same as saying that GH is HG.